Okay, so the elimination method says we need to eliminate one of these variables, right? So we're going to eliminate either the x's or the y's. Which one should we eliminate in this case? The y's, you reckon? Okay. If I've got 1y and I subtract the second equation, 1y taking away a negative y will give me 2y's. True? So I didn't eliminate the y's like I wanted to. The reason is because I subtracted when I really should have added. Okay? So let's try this again. 1y plus a negative y will give me 0 y's. Okay, so that's how I eliminate the x's, it's by adding the second equation. 1x plus 1x is equal to 2x. And 9 plus 7 makes 16. And if 2x's make 16, that means 1x is equal to 8. Yeah? Now, let's use equation 1. Equation 1 says x plus y is equal to 9. That means y has to be 1. Okay, so what this means is that we have a coordinate now that is equal to 8, 1. That there is the point of intersection. Okay. So if we graph these two functions, we're going to find that the point of intersection is 8, 1. Okay. Perhaps I could show that to you very briefly. So this graph here is going to be y is equal to 9 take away x. So there's 9. If we move the x across, it's negative x, which means the gradient would be -1. Hopefully you can see that. And so we've got a graph that looks like this. Okay, that's equation 1. Are you still with me? Yeah. I better write this then. So this is y is equal to -x plus 9. Sure? That's the same equation. So you can see the gradient there is -1. Down 9 across 9. This one would be the same as saying y is equal to x take away 7. True? Which means the gradient is 1, and I'm going to start at -7. So if this is -7 here, go up 7 and across 7, then this equation will look like that. Okay, so now you can see that 8, 1 seems reasonable for the point of intersection. Okay, let's have go to the next one. X take away 2y is equal to 12, and then 2x plus 1y is equal to 1. Okay, which variable do we want to eliminate this time? Aaron?
The x's?
Do we want to eliminate the x's? Okay, I've got 3x there and 2x there. How would I eliminate the x's? Subtract them. If I do 3x take away 2x, I'll end up with 1x. It won't eliminate the x's. At least not by subtracting alone. Any other ideas? Okay, I would be doubling the second equation like this. If I double the second equation, I get 4x plus 2y is equal to 2. Okay? So what I've done here is I've doubled equation 1. I'll write that as equation 1 times 2. And so now it's obvious which one we're going to eliminate. Which one is it? The y's. Am I going to subtract the y's? No? I'm going to add, aren't I? Okay. -2y plus positive 2y, I'm going to get 0 y's. 3x plus 4x is 7x. And 12 plus 2 is equal to 14. That means x is equal to 2. And now we need to solve for y. Should we use equation 1 or equation 2? I could use equation 2, but I'll use that one there. That's even better. So equation 2 says 2 times x plus y is equal to 1. That means y is equal to? Negative 3. Thank you, Pearl. So the point of intersection is 2, negative 3. Yeah? Now, is there a way to check our answer? Yes, there is. There always is with algebra. Over here, we checked our answer using a graphing method. Over here, let's try using the second equation. Okay, let's do that. All right, let's do a little check. All right, let's say we use equation 1. 3 times x, which is 2. Take away 2 times y, which is negative 3, gives us 6 plus 6, which is equal to 12. 12 is what we wanted. Left hand side is equal to right hand side. We did it right. Okay. If we use the other equation, would it have worked as well? Yes, it would. Do I need to show you that? Okay, I'll do that then. So the left hand side says 2 times x, which is 2 times 2, plus y, which is negative 3. That comes to 4 take away 3, which is equal to 1. And 1 was what we wanted, right hand side. So left hand side is equal to right hand side. We did it right. Yes, Pearl?
Why is it that you're just allowed to double one of the equations?
I'm allowed to double this equation so long as I keep them balanced. So what I do to the left side,
So
I can do to the right side. And that way it remains proportional. Okay, so you're allowed to double, triple, quadruple, do what you even have it, so long as you do it to both sides. All right, one to go. Let's do 3x take away 2y is equal to negative 4, and 6x plus 5y is equal to 37. Which one should we eliminate? X's or y's? X's. Okay, we all seem to agree. Right, so how do I eliminate the x's? Double the first equation, yeah? So if I do equation 1 times by 2, I get 6x take away 4y is equal to negative 8, and 6x plus 5y is equal to 37. Am I adding or subtracting the equations? Subtracting this time, that's right. 6x take away 6x is 0 x's. Negative 4y take away 5y makes negative 9y. And negative 8 take away 37, what's that come to?
Negative 45.
Negative 45, that's right. Good. So tell me what y is. 5, yes. Very good. So if y is 5, we can solve x. Now choose the easier of these two equations. The top one is perhaps easier. So if we say equation 1, and we say 3x, take away 2 times y is equal to negative 4, then 3x is equal to negative 4 plus 10, which is 6, and that means x is 2, and our point of intersection is 2, comma 5. Do a quick check. Pick an equation. Well, only 1 or 2, so you've got to go 50-50 on that one.
2.
Alright, here's the rule of thumb. If I pick equation 1, if I solve the question using equation 1, if I solved it using equation 1, do I want to check using equation 1? No, because I could make the same mistake twice. So rule of thumb is if you use equation 1 to solve, you use equation 2 to do your check. Okay. Alright, here we go. Left-hand side is equal to 6x plus 5y. X was 2. Y was 5. And that makes 12 plus 25, which comes to 37. Excellent, did it right. Okay. Your turn.